So hello everyone and welcome to HashiTalk 2023. My name is Jonathann Zenou. I'm head of DevOps at Windward, and today I'm going to explain you how Terraform is helping us catching bad guys at sea. So we are Windward. We are a maritime AI platform. We are listed at the London Stock Exchange. We've been one for 12 years. Our offices are located in 4 locations in the world. We have several AI models, and we have 160 employees managing those AI models. Our diversity of activities is split between sanction compliance, security, environment, and so on. And we are working with big customers like Waypoint, generally, ADNOC, and so many more. So how does it work? How are we helping catching bad guys at sea? So first of all, we are transforming our data into insight. How do we do this? We are acquiring data sources like identity, location, ownership and management, cargo and container about all kinds of vessels. From this data, we are creating entities. By linking entities together, we are creating voyages. From analyzing voyages, we are detecting patterns. And from pattern, we are pushing recommendation. Now we are pushing this into our system, and then our customers that are using our security, safety, client, supply chain, environment, our customized product are able to see those insights. Now, those are a lot of beautiful words and beautiful expression, but I think it's best to look at an example. So this is the Eolica. The Eolica is a typical cargo ship. It's not a big one, around 80 meters. It's been one for quite a while, since 1983, and it's operating under the Guyanese flag. Now, being over a certain tonnage, the Eolica fall under the regulatory law that is forcing him to have on board what is called a transponder. It's a box that at any given time is telling the exact location of the Eolica and all kind of information about it. Now, thanks to this transponder, we are able to analyze the behavior of the Eolica. So let's dive in. So what we are seeing here are 2 main information. The first information with the blue line is the transmission. We are seeing when the Eolica transponder is transmitting and when it isn't transmitting. And what we are seeing under is all kinds of changes in the identity of the vessel. So if we are looking at the transmission, we are seeing a big gap between 2020 and 2021. Our ship is working like a human being. What does it mean? It means that in order to live, it has to work. So when you are seeing such a gap in the transmission of a vessel, it's like if you are watching the resume of someone for an engineering position and you see a big gap into the resume. It doesn't mean that something is shady, but it raises some question. And here about the identity, we can see that exactly at the same time where the Eolica got out of its transmission pose, it changed its identity from the Eureka to the Eolica, and it changed from the Panamanian flagship to the Guyanese flagship. Once again, those are 2 kinds of operation that are not enough to detect something shady in the behavior of a ship. But let's continue to dive in. What we can also see from the behavior of the ship is that it changed at the same time. It also changed ownership from a specific Lithuanian company that we will call Company X. It moved to a UAE company that we will call Company Y. And a few days later, it got back to the Lithuanian company called X. Still, it's not the best practice, but sometimes only this behavior doesn't mean especially that something is shady. Let's continue to dive in. Here what we are seeing are the movement of the ships. We can see that the Eolica is mainly navigating in the Mediterranean Sea, but out of nowhere, it decided to leave its usual Mediterranean course to go into West Africa to the Senegal coast. This specific behavior starts to be a little bit shady, but if you add all the behavior that I stated before together, and you see that it is falling onto the same timeline, then it can be something very problematic. And that's why we decided to flag in our system this ship at a high risk. And not with a lot of surprise, a few weeks after we decided to flag this ship as high risk, we could see that the Senegalese authorities decided to go on board and to seize a big cargo of munition. So this is how Windward is helping catching bad guys at sea. So now that you know what is Windward is doing, let's see and let's dive in how does it happen from a technological point of view. So this is the life cycle of a deep learning model. We are starting by developing the model, developing the algorithm. Then once the algorithm is ready, we are deciding to create a project where we will create a repository, start to build the code, start to deploy it. And then when it will be ready to deploy, we will deploy the code in the microservice and queue architecture. This is a little bit of the model lifecycle. Now, what we'll do today is seeing how each one of those steps is working, but especially how does it work with Terraform. So let's start with the model development. Usually when we are developing a model at Windward, this is how it does. This is how it happens. We are starting by receiving a problem from the product manager. Usually it can arrive from some customer or from some research that they did. Then the data scientist will try to understand the problem. Then we'll start a phase that is called EDA, exploratory data analysis. During this phase, they will check the different data sources. Then they will continue their investigation from the Jupyter notebooks. From there, they will run and will create some graph. Then we'll open some Spark context in order to analyze furthermore the data. Then we'll start identifying the pain points in the problem and start to imagine how will the solution looks like. After that, we're arriving to the case where we have some predefined data use case, and the big problem has been split into several sub-problems. And at this moment, we are starting to checking existing models that could solve the problem in question. And if from the existing model that we are picking, we decide that we need a deep learning model, then we will need to train the deep learning, but it's called the GPU. So GPU stands for Graphing Processing Unit. For those of you who don't know what the GPU is, if you have a graphic card on your computer, then it is a processor of the graphic card, okay? And in 2009, a team of researchers at Stanford discovered that using GPU for training data model is way more efficient than using CPU. And of course, working with GPU has a lot of advantages. It has better scalability. It works better from a power efficiency point of view. It has a higher memory bandwidth. It's cost effective when you are using it in cloud-based GPU instances. It's available in a lot of places. You can have it on desktop. You can have it on laptop, of course, in cloud instances. And you are even some GPU chip in a smartphone today. But I think the main advantage that GPU has on top of CPU is its speed. It works way, way faster. But working with GPU has several problems. First of all, it's very expensive. It costs way more than having a normal CPU server. Okay. At Windward, we are working with AWS. And when we want to create spot instances for GPU server, it's almost impossible every time those spot instances are being taken back from AWS. Okay. So we have no choice but to work on on-demand instances. And because we are working on on-demand instances, it's very expensive. It's even more expensive. And we have no choice but to split the way that we are working, meaning that we will start the instance, it will run during the whole day, and then we'll have no choice but to stop it, so it won't run during the night. And the problem with that is that at the next morning, we will need to be able to continue exactly where we left things the day before, okay? On top of this, what we're going to do is to monitor what is happening inside the servers, and we will want to be able to share those GPU environment easily between different engineers. So Because we were running with GPU instances for several years at Windward, even before we started to use Terraform. In the past, we were solving the solution using SaltStack. SaltStack is a state configuration management system like Puppet and Chef. It's written in Python. It works with master-slave architecture. And in our solution, we had a Jenkins job that is receiving all kind of parameters. And this Jenkins job were running as a salt master as a Jenkins slave, and it was running the salt command. The salt, I'm not really happy about the solution of having the salt master as a Jenkins slave, but this is what it is. And when it was running the salt stack command, what it was doing is creating the server from scratch and starting to configuring in all kind of, installing the different dependencies, configuring the different users, creating the different files, and so on and so on. What we decided to do on top of this is to connect the server to an external EBS disk so we can save all the data folder externally. We were creating some Route 53 records in order to be able to share the environment easily between the different developers. And we were monitoring what was happening inside the server by running collectd, and then the collectd was sending the metrics to a Grafana server. And this is what we were working with SaltStack. A tiny precision here, we were all the time needed to be extra careful of releasing the EBS disk before we are destroying the server. So because if we did not release it, we were losing the EBS disk. And by losing the EBS disk, the data engineer was losing all of these works and all of the training of the models. So yeah, it had a lot of limitation. So then when we started to work with Terraform in the company, it was one of the first flow that we wanted to move to Terraform. So first of all, we stopped using Jenkins job and we started to use Jenkins pipeline. The Jenkins pipeline in question was connected to a Kubernetes cluster in order to run the Jenkins slave. So it was running a pod template. The pod template was has attached to it an AEM role. And inside the AEM role, you had all the AWS permission that you needed in order to create your resources. So when you are running Terraform, what it is doing is that it is creating a GPU EC2 instance based on a pre-cooked EMI, where inside the EMI, you have a lot of the dependencies that you need. Instead of connecting your EC2 instance to an EBS disk, we decided to connect it to an EFS storage. The good part about it was the fact that right now we have the possibility to create several GPU environments that are all connected to the same data stores. So if you have, for example, two engineers that are working on the same project, each engineer can have its own GPU environment, but they are all working on the same model and training the same model. We continue having our Route 53 entries in order to share the environment easily between the engineer. Now we are monitoring this instance using CloudWatch metrics and CloudWatch alarms. We are also using Terraform to create the data sources and to create the data environment for our GPU environment. So RDS instances, S3 bracket, etc. And if we have some kind of script of some kind of commands that we need to run as part of the process, instead of running in as a local exec with Terraform, we decided to use Cloud Init. Cloud Init is an infrastructure that you can inject some kind of script into your EC2 instance creation. And at the boot time, it will run your script and it will do all the things that you need. So at the end of this process, what we have is a working GPU environment. So the engineer receives his GPU environment, work on its model, the model is ready, and now arrives the next step. The next step is to take the model and to productize it. So the next thing will be for us to create a project in order to use this model. So the project creation at Windward works like this. First of all, let's create a repository. A GitHub repository, because GitHub is our revision control. Then we will insert some code inside the repository. For example, if you have a Python, if it is a Python project, then you know that you will already have the same kind of file and the same kind of file structure into your repository. Then you will want to configure your repository. For example, you'll want to have this team that will have permission on the repository. You will want to have this branch to be protected. You will want to have this webhook to be configured, etc. And then after that, you will want to generate the Jenkins pipeline that will be connected to the repository in question, that will be created into the Jenkins master. And so you will have your full ecosystem for your project. So first of all, in order to work with Terraform and Jenkins, when we started to create this flow, we decided to use something that was created in-house. So we created a lot of the thing by ourselves. But if I had to do it from scratch, I know right now that there is this provider. It's a very cool provider. It's very easy to use. So I strongly advise you to use it in the future when you need to create any kind of integration between Terraform and Jenkins. But for the integration between Terraform and GitHub, we did use the official GitHub provider of Terraform. And since I've been using this provider, I never found something that I were able to do in the GitHub console that the Terraform provider was not able to do. It has literally everything, every aspect of GitHub is being served by this provider. It's a very cool provider. And for example, we are using it in order to create branches into the repository, in order to create protection on the branches, in order to set branches as a default branch, and so on and so on. We can also, if you see here, we can also require some status checks on the specific branch. Or also what we can do is this is how we are managing team and collaborator into the repository. Very easy, very straightforward. We can also define webhook directly on the repository using Terraform. So then it will be very easy for your Jenkins job to be connected to your GitHub repository using the webhook. But still, there are a few pitfalls when we are using GitHub and Terraform together. So at Windward, we have around 600 repositories. It's not a lot. I know there are companies that have way more repository than us, but it's not few either, okay? And because in our Terraform flow, we have in GitHub, we are creating between 40 and 50 resources on each project. And we have 600 repo. And based on the fact that every time that you are creating new resources or a new project, Terraform is checking the state of all the other resources and all the other projects, you can easily imagine that at the beginning, when we started to create more and more repositories, the time that it was taking us to run the Terraform to create those resources was very long. And take in account that as long as this time was, you need to run it twice, once for the plan and one for the apply. So with the time, we understood that we could not continue like this. So what we decided to do, instead of having one big TF-var files with all of our repositories, we decided to split it between categories. So today we have one TF-var for Python lib, one TF-var for Python apps, one TF-var for Python service, and so on and so on. And working like this has enabled us to have our Terraform flow running faster. So far, we talked about the model development part. We talked about the project creation. And now I would like to talk about the microservice and queue architecture and how Terraform is helping us on this part also. So first of all, microservices. At Windward, we are using Kubernetes with EKS. For those of you who don't know what EKS is, it's the managed version of Kubernetes for AWS. And we are using Helm for templating. On top of this, we are monitoring those environments using Prometheus. And from the autoscaling point of view, we are using a combination of Carpenter and Keda. Carpenter, for those of you who don't know what it is, it's a provisioner that lets you manage the node aspect of the cluster directly from the control plane. So instead of having one process that is managing your Kubernetes node and one process that are managing your Kubernetes services, you have one process to manage both, okay? And Keda, it's a Kubernetes event-driven autoscaling. For example, at Windward, we are using AWS HQS queues quite a lot. And in order to create an auto-scaling of a Kubernetes service based on it, is as easy as that. You define the queue, you define the queue length. So based on this example, every time that we will have 5 objects in our queue, it will create an additional replica in Kubernetes. So I'm telling about this to introduce the subject of the queues architecture at Windward, okay? We have around 200 SQS active queues. We have around 60 SNS active topics, okay? And we are monitoring all of those queues and all of those topics using CloudWatch metrics and CloudWatch alerts. For those of you who are not aware what are SNS and SQS, okay? So SNS are like topics that are connected to one or several queues based on a filter. So instead of having your application that need to open a context to each queue, you can have your application opening a context to SNS. And based on the filter that you will have inside your SNS, the message will either go to 1 queue, 2 queue, all of them, or none of them. Everything based on the filter. So if you think about it, it seems like an easy task in Terraform. You have the AWS provider, you have the AWS SQS queue and the AWS SNS topic. Very easy to use. For Terraform, creating and managing CloudWatch Alert is pretty straightforward. It's pretty easy. But at Windward, we have a few problems with that. So first of all, at Windward, the DevOps team is the team that runs Terraform. Not everyone in the company has permission to do everything. So usually when we need to run Terraform, it's back to our team. Also, and that's the real problem, and that the main problem about this is the fact that non-DevOps team in Windward don't know Terraform syntax. They never worked with it, so they don't know how to use it. Add to this the fact that the DevOps team need to review every infrastructure pull request, every changes that we want to do in a pull request in our infrastructure need to be reviewed by the DevOps team. But the real pain point here is the fact that those SNS SQS topologies changes quite a lot, almost on a daily basis. And on top of the changes in the topology of the SNS SQS, there are also a lot of changes in the monitoring of those SNS and SQS. People want to change the threshold, people want to change the severity, and all of those changes, the DevOps team being the navel point of those changes and who are running those changes, it started to eat a lot of time for the team. So one of our engineers in the team had the following idea. First, we decided to create a big JSON file with a predefined structure that is describing our SQS with all the relevant fields. And after that, that is describing the SNS that is part of the SQS. And what we are doing is that inside, when we are running our Terraform flow, inside our variable TF, we are reading the JSON file in question. And based on it, we are creating a list of dictionaries. And then it's really easy for us into our resources to iterate on top of this list of dictionary and to create the resources based on it. And then it's really easy for us to create the resources and so on. The first thing that it is doing is that our engineers are able to create pull requests for us without knowing Terraform. But what we are doing is that we are defining a different JSON file for each big project. So each big project can have its own JSON file with its own queues and topics definition. We are also keeping another common JSON file for all small projects. And every time that someone is opening a pull request on one of the JSON files, the DevOps team is reviewing it, is decided to merge it, and then we have a Jenkins job that wakes up and applies the Terraform changes every time that the pull request is being merged on these repositories of infrastructure. Of course, on top of this, we are monitoring, the Jenkins job is monitoring that the Terraform flow is not running any destroy. So in case someone deleted the field in the JSON and Terraform detects this as a resource destruction, The job will fail. It will contact the DevOps team, and then we'll investigate what is happening here. But it still have a few limits. First of all, those JSON files can be pretty big and can get very big in the time. It is not helping our situation of teaching Terraform to the non-DevOps teams because they are continue working with the JSON file in question, and it's still a lot of pull requests to reviews. And I think the more and more we work with this project, and we understand that at the company, we rather arrive to the point where we need to streamline Terraform to the R&D and to get it out of the DevOps team. And we understand that we arrive to the point where we will need to start using some tool for that. So we are seriously considering starting to work with Terraform Cloud. But also there is a very nice startup company called N0 that I strongly advise you to read about. They are helping you manage your Terraform infrastructure, and it's easily integrated with your revision control. So give them a look; they are very good. So, in conclusion, at Windward, we've been helping catching bad guys at sea, and we've been doing it before using Terraform, and we continue doing it after we started to use Terraform. But since we use Terraform, a few things had improved. First of all, we are way more stable. The fact that we are using Terraform has really reduced our errors when we are creating infrastructure. Also, it makes our infrastructure changes faster because based on the fact that we are still managing the same state, Terraform detects only the changes that we need to do and does this quickly. We don't copy our code anymore. When we were working with SoulStack, we had to copy environment on top of another, and it was a lot of code clone. And now we can simply creating Terraform models, and it is helping us not to copy our code. And finally, every time that I'm working with Terraform, even if right now we are only working in one region, I know that the day that we will decide to move to a multi-region, I know that for us, it will only need, now all of our infrastructure is being managed by Terraform. For us, it will only mean creating a new TF var files with the relevant region, and that's it. We'll be able to completely deploy everything in the new region. So thanks, Terraform. And thank you for listening to me. It was my honor to talk to you, and have a nice day.